Hello, and welcome to 5-Minute Math. Today we are looking at the 5th grade concept of area, perimeter, and volume. This is 5.4H Readiness Practice, the Proficient version. If you are interested in exploring the 5.4H Readiness Practice for the intermediate or advanced versions, or the Readiness Practice resource line with any other standard, you can find those by using the link in the video description. So we have a rectangular garden, and we have a plot that is 8.5 feet wide. We need to find the length. So let's draw a rectangle to kind of help us visualize here. And let's just say this is our width, 8.5 feet. All right, so 8.5 feet is that side. So we can also say this side is 8.5 feet. Now, the whole perimeter equals 46 feet. All right, so what is 8.5 and 8.5? Well, 8 and 8 is 16. Add the two halves, you have one extra hole, so there's 17 feet. So between these two is 17 feet. Now, here's my question. How much is left over for the top and the bottom? So let me take that 17 feet. I'm going to take this away, and that's 29 feet. All right, so between these two right here, I'll draw it like this. I'll say 29 feet. Go between these two. Now, the answer is not 29 feet because I need to split that in half. It's the same distance across the top and the bottom, the length. And so we need to take our 29 feet and we need to cut that in half. So let's divide that by 2. And that is going to be, let's see, that's going to be 4. And we've got just that one left over. So it's 14.5. Now, since they gave it to us as a mixed number, 8.5 rather than 8.5, let's call it 14.5 because we know that 0.5, 5/10 is the same as 1/2. Now, to verify, let's just add them up. 8.5, 8.5, 14.5, 14.5. So the halves gives us an extra 2. And so we're going to get 16, 20, and then 26, and then 46. All right, so we've got our 46 back. And so let's put our length here. And we'll need to make sure to include our unit is 14.5 feet. And since we've got a lot going on here, let's put a green box around it. Next, we have a rectangular storage with a base of an area 48. We have a filled with sand up to 5 feet, so we need the volume of the sand. All right, so let's draw a three-dimensional shape. All right, so I'm going to draw a rectangular prism, and I'm going to draw it like this. So what I like to do is I like to draw two parallelograms kind of as much as possible, try to make them congruent and parallel. So I'm going to end up connecting the lines here. And then I like to draw the one in the back with a dotted line just to help me visualize that it's in the back. All right, so here's my rectangular prism. That's close enough. So the base, and I'll make that in green. So B equals 48 square feet. So sometimes they'll give you on these volume problems the length and the width. You have to multiply those to find the base. In this case, they just gave you the whole base. And then we've got a height of, let's put that right here, 5 feet. Well, you'll see the volume two different ways. You'll see length times width times height. And that's really how we learned it the first way in 5th grade. But by the time we get to 6th grade, we've kind of shortened that. We take our length times width equals the base. Now, we typically show that with the big B. So if we want, we can make a big B down here. Means the area of the base. And then we multiply that by the height. And so they've already given us the base. The base is 48 square feet. The height is 5. So all we need to do is multiply those two, and we've got our answer. So that's 40, 200, 240. So we'll say the volume equals 240. Now it's not square feet, it's cubic feet. You can either write it like that or feet with an exponent of 3. That also means cubed. So 240 cubic feet, because volume is cubes. Now we have a rectangular container with a volume of 360 feet. The base is 30, so now we need to kind of go backwards. Let's do that same thing that we did. Let's draw our visual representation. Trying to make some of those dotted to visualize that they're in the back. And then we will see again if we can draw a parallelogram that is that same shape. All right, so that's going to have to work. We're going to kind of do this right here. Now, what do they give us? The volume. So they give us the volume, 390 cubic feet. And I'll write it like this. This time, this is the other way to write cubic feet. The base is 30, so they give us the base again. Okay, so big B equals 30 square feet. I'm looking for the height. That's my missing number. Well, remember, volume equals base times height. So since my volume is 390, I can say 390 equals, my base is 30 times height. So 30 times what gets you to 390? Well, there's a few different ways we can do this. We can go up by 12s as much as we can, right? So 3 times 12 is going to get you 36. So that's going to be 3 times 12. And since it's 30, I could just make it 30 times 12. That's 360. And then if I just add another 30, right, that's 390. So really, it's going to end up being 3 times 13. Or you can think, the opposite of multiplication is division. If I'm thinking I need to multiply something by 30 to get to 390, let's just take our 30 and divide it into 390, see how many times it goes in. Now, we still have to end up doing a little bit of division here, so 30 goes into 39 once, but it's a little bit more manageable than the first way I showed you, and this can be 3 times. All right, so the height equals 13 feet. So I'll put that right there, 13 feet. That is our height. If you're interested in exploring the 5.4H Readiness Practice resource aligned with the intermediate or advanced version, or the Readiness Practice resource aligned with any other standard, you can do so by using the link in the video description.